Welcome back to Mrs. Schroeder's chemistry class. We're going to continue talking about Chapter 10, Causes of Change. The section we're going to cover today is called Using Enthalpy. Our objectives today are to talk about what thermodynamics is and then how to calculate enthalpy for a given amount of substance for a given temperature change. Thermodynamics is the branch of science that talks about energy. Any kind of chemical changes or physical changes that have an energy change associated with them are part of the branch of thermodynamics. As you get into college, you will perhaps take a class on just thermodynamics. We're going to cover just a basic understanding of it, touch on what it is. There's a lot more to thermodynamics than what we're going to cover in this course, but it gives you an opportunity to see what a little bit about what it begins with. It's important because it helps to predict whether chemical reactions can occur. So in chemistry, we want to know, we put these things together, is this reaction going to happen or not? And then if it does happen, is it a lot of heat generated, or extremely explosive kind of heat? Is it take energy in to make it happen? How does that work? So we have this term, which we're going to define as enthalpy. The symbol for it is a H. Don't know why. Capital E would be energy, so they don't use E, they use H, enthalpy. It's one of the three thermodynamic properties. It's the only one we're actually going to talk about in this class. And what it is internal energy plus pressure times volume. And that's the definition of enthalpy. Now, the problem with enthalpy is the only way you can actually measure it is by changing it. You can't go to some kind of system and figure out how much enthalpy is in it unless there's some kind of change that happens. So for 1 mole of pure substance, we call a molar enthalpy change delta H. And this is the term that we're going to be looking for in this class, is what delta H is. So when the substance is only heated or cooled, the amount of heat is the same as enthalpy. And we've been looking at heat. Heat is Q. And we've been doing heat back in Chapter 2, again earlier in this chapter in Section 1. We've been looking for the amount of heat involved. And again, if it's only heated or cooled, pressure is constant. Q equals delta H, if these other conditions hold true. So right here, Q equals delta H for heating or cooling. Therefore, the molar enthalpy change is C, the specific heat, times delta T, is the molar enthalpy change. It does not apply if we change state or we have a chemical reaction. In that case, we have to find enthalpy in a different way. So enthalpy changes are used to determine, again, if a process is going to be exothermic or endothermic, and to understand if it's going to happen or not. If it's a positive enthalpy, it's endothermic. Positive means enthalpy is taken in. Energy is taken in to make that happen. Negative enthalpy are exothermic, so you see a negative sign, negative delta H. So we're going to try to calculate the molar enthalpy of a change if I have liquid water, which is heated. So if I'm heating something up, is it going to be endothermic or exothermic? If you guess correctly, you guess it's endothermic. It's taking heat in order to make it get hotter. So I'm going to start with my delta H equals C times delta T. That's the molar heat capacity, or the molar enthalpy change. C is the molar heat capacity, which I can look up. For liquid water, it's 75.3 joules per K per mole. And I've just looked that up on the page 343. There's table 1. So look at that in your book and see how I found that. Temperature change. Remember, it's always T final minus T initial. So 76.2 minus 41.7. So my temperature change is going to be 34.5, okay, and that's going to equal 2,598 joules per mole. So if I have 1 mole, it's 2,598. If I have 2 moles, it's 5,200 approximately. I can figure out how much the enthalpy changed based on how many moles I have, but this is the molar enthalpy change for this system. So I can write enthalpy changes as an equation, like a chemical equation. For example, if I have my liquid water, which I just did, it's going from 41.7 to 76.2. I write it down. Here's my water. L is the state for liquid. That's the temperature that it is. It shows the arrow means it's going to, or it's changing, to water, which is also still liquid, the new temperature. And the delta H for this reaction, or for this change, 2.6 kilojoules. Again, I had 2,598. If I divide that by 1,000, that's approximately 2.6 kilojoules per mole. And that's the delta H for this reaction, or this change in the chemical substance. Now enthalpy changes also occur when we change state. If I go from a liquid to a gas, the energy changes significantly. If you've ever been burned by steam, you know it's got a lot of energy in steam. Enthalpy is very high, a lot of internal energy. But I don't calculate that change of state using C delta T. We'll learn how to do that next week. Chemical reactions also have energy changes associated with those. Those are usually given. Somebody at some point has done a lot of experiments and figure out what the energy change for 1 mole of substance is. So I can use chemical equations to show the enthalpy change for a reaction. So if I have hydrogen gas, there's hydrogen G for my gas, that's my temperature, 298, plus bromine, which is Br2, is a liquid, is 298 K, and it goes to HBr. Then there's 2 of them. Delta H is 72.8 kilojoules, which means that for every 1 mole of hydrogen and 1 mole of bromine that react, so for every 1 mole of this reaction, I'm going to have 72.8 kilojoules released. Released because I see a negative sign there. Negative sign means it's exothermic, it's released. And that's all we're going to cover for today. So again, the difference between our enthalpy change and our energy change. Energy is just talking about heat in general, heat being transferred. Enthalpy is talking about something per mole of a substance. And I can calculate that with my equation, C times delta T, and that's molar enthalpy change, delta H.